What's up? We're gonna be doing week 4B homework here, and I'm gonna go ahead and start with question 5. I do like this question. I had to search up what a toboggan was, but we learn. So it asks a person pulls toboggan for a distance of 31.7 meters along the snow with a rope directed 22 degrees above the snow. The tension in the rope is 92 newtons of force. How much work is done on the toboggan by the tension force? How much work is done on if the same tension is directed parallel to the snow? I already obviously have the correct answers here, but we're going to be doing the work. So let's draw the picture here first of A. So it's going to be a person carrying a rope to the toboggan, 22 degrees. This is 22 degrees right here. Let's see. Looks something like this. And the tension force is going to be 92 newtons. Let me make sure. Yep. 92.0 newtons. And we're going to have the tension force here, tension, and the friction that's pulling back, just in case you needed that one. That's the thing that's pulling back. No force is acting up or down up on this, but since it is asking for tension force, we are going to be using the equation W equals F D cosine of the angle. And since we have everything already, considering we have um, F for the tension, so let's just plug in here. We have F for the 92 newtons of tension, so that's F, 92.0. We also do have the distance, which is given in the problem, 31.7 meters. Just put that here. Oops. 31.7, so 31.7. And we do have the angle given. It is 22 degrees, so we're going to do cosine of 22. And this comes out to be, let me see here, 2,704 joules. 2,704 joules. Boom, let's check. That is correct for A. Now B is asking how much work is done if the same tension is directed parallel to the snow. So, we want to go ahead and put the problem here. Same stick guy, but instead he's going to be pulling it as if it was a straight line with the toboggan here. Boom. So the degree is obviously going to be 0. Right off the rip, let's just take it off. It's going to be cosine 0, which is equal to 1. Just so we know here. Just keep that in mind. But it's the same exact number, same exact everything. So what we want to do is W equals, the only thing that changed was the degrees. Now it's 0 degrees, cosine 0 equals 1. So it's going to be 92.0 times 31.7. Also have the same forces here, tension equals 92.0, and then friction going this way. No angle, and the distance is going to be 31.7. And since we're multiplying this by cosine of 0, it's just going to be 1. So W is going to equal 2,916 joules as the final answer for B. And yeah, that was the first question I wanted to do. The next question I wanted to do was question 12 here. A man carries a, let's just do this. A man carries a 12-kilogram chair up one flight of stairs to the second floor of his house. If the second floor is 3.3 meters above the first floor, what is the change in the gravitational potential energy of the chair? Potential energy. So, a man is carrying a 12-kilogram chair. Pretty big chair. So, The weight is going to be 12 kilograms. He wants to carry it up one flight of stairs to the second house, to the second floor. And the second floor is 3.3 meters above the first floor. 3.3 meters. So we have the mass and the height, and we're looking for potential energy. And gravity's gonna have a play at this. Gravitational force is gonna be here. Gravity, his normal force is gonna be up here. And then we're gonna do potential energy. Total potential energy is equal to WGH, I presume, or sorry, MGH. And we're gonna go ahead and just plug in here since we have all the numbers. So this will be equal to 12, right? Let me check. Yes, 12 kilograms times 9.8 gravity times 3.3, which is the height. And we get it equal to, 338.08, which is just rounded up to 390 joules. Since we are talking about potential energy, we need to make sure that we can tell if it's positive or negative. In this situation, it is positive because the chair is going up. So the potential energy is increasing. Right, up is positive. And it does come out to be 390 positive joules. And yeah, those were my 2 questions for week 4B Jedi lessons.